Alrighty. Nope, that's not it. What is happening? All right. So here is my Tinkercad circuit. We already went over this, okay? But I'm just gonna do it again so that we can record it. But once I have the circuit set up, really, really important that your NPN or PNP transistor, the collector, the base, and the emitter all are on different rows. They have to be electrically disconnected, okay? So make sure, because a lot of guys, common mistake is that they plug it in like this, where all three of the leads are at the same voltage level. So no current's going to flow that way, right? So you want it to, all three have to be in a different row. So I will start my simulation here. Okay, and the way this works, the way the circuit should work, is that when the input light is low, the resistance here is high. If the resistance here is high, it means that the voltage, okay, I shouldn't say high, but it's higher than it is, it's at 4.48 volts. So what that means is that at the base, I have 4.48 volts, right? Oh, hang on one sec. Sorry, scratch that. This voltmeter should be not there. It should be here. Sorry, that's my fault. All right, so we're figuring out the voltage across the LDR, because I know that electrically row 9 and row 15 are connected, right, through this green wire. So let's try this again. We're going to start the simulation, okay? So right now, when light is low, it means the resistance here is high, okay? So what that means is the node here, let me just make sure this is working. Yeah, so the node here is getting a higher voltage than it would, okay, if the light is bright. When the light is bright, I can see that the voltage at the base goes down. Okay, so when the voltage is higher, that means current is flowing. And when the voltage is lower, current is not flowing. So let's think about that again. When there's no light, the resistance on the LDR is higher. I mean, it's not high, but it's higher, meaning that the voltage at the base of my transistor is higher. And remember how I said just a little bit of base current causes a lot of current from collector to the emitter 100 times. Okay, so once I bring this up to 6 point, that's not even a volt, right? It's like 0.7 volts. That's enough to turn this transistor on. Okay, transistors are really low, like they need low voltage to turn on. Okay, but if it gets sunny, my resistance here goes down, meaning that the resistance into the base goes down and my transistor turns off. So 111 millivolts is not enough to turn the transistor on. So now that we've done it in Tinkercad, what I want to do is, I'm going to do this again, but I'm going to do it using the circuit. Okay, so let's go back to, this will be in your notes, and obviously it's also going to be in the video. But what your quiz is going to look like will be more like this, okay? So what I'm, okay, so guys who have NPN, the question on the quiz is going to be about, sorry, the guys who have PNP, the question on the quiz is going to be about NPN. So I'm going to give everybody the same question. But basically, you have to be able to explain this circuit. So here's what I'm going to do. I might actually need copy. So I'm gonna just put in a page here. Okay, and we're going to talk about how this works. Okay, and the way I want us to think about it is the best way to start explaining this circuit is to look at the LDR. Okay, so, and actually I'm gonna paste this one more time. Here we go. Here we go. What happens when the light is bright? Actually, maybe we'll start with when the light is dark. How do I show dark? We'll make this gray. Sun is gray. It's dark. Say dark. Okay, so here's what you have to know. When the light is dark, what can we say about the resistance of the LDR?
It's high.
Yeah, so the resistance is high. And when I say high, I mean it's relatively high. The highest resistance on an LDR is not that high, okay? Like, it doesn't have to be like, it's higher than it is when it's bright. So if the resistance is high, so this is thought 1, this is thought 2. Thought 3 is what happens here? Tell me about the voltage here. What did we say about the voltage, the Vout? We said it's going to be the same as the voltage across the LDR because we know this is ground. So if I know that my LDR resistance is high, what do I think at 3? Is the voltage high or is the voltage low? This. I know I see some of you guys with your heads down working on your circuit. I think we should listen to this, okay? So, it's dark. The LDR has high resistance. What do you think, Adam? Is the voltage high or low?
High.
Yeah, so here at this point, voltage is high. We're talking relatively high. And so what that means, step 4, means that I have current flow. It means that there is a current going into the base, enough to turn the transistor on. Current flows. So what happens to the LED?
Turns on.
Yes. So the 6th thought here, the point is dark, on. Okay? Can we do this?
I have a quick question.
Yeah, sure.
So does that mean if we raise the voltage, like, I don't know how much, but if you raise it enough, even if it was bright, the light would still turn on?
Yes. So you know how that where that matters is the value of R1. So if R1 is too low, this circuit, that your LED will always be on. Actually, that's a good point, Haniel. That might be why some guys are having trouble. So R1, remember we said R1 is 20,000 ohms. So if you're having trouble where your light is just always on, you might want to up that. But the thing is, even if it's always on, as you make the LDR darker, the LED should still get brighter. So the fact that guys are covering up the LED and the LDR, and the LED is getting dimmer, something's wrong there. So I'm going to try my best to troubleshoot over Zoom, but it's going to be tough. We'll figure it out. Even if it doesn't work, I'm not that heartbroken. I want you guys to understand this circuit. Okay, and I mean, if we were in person, we would all have working circuits, but you know, I think we did okay over Zoom for this unit. Okay, we're going to do the exact same thing, Okay, but we're going to talk about what happens now when the light is bright. Okay. So it's essentially the opposite. So step one, or thought one, is that the light is, I'm going to call it bright. Okay, so we have ambient light shining on this LDR. So tell me about the resistance of the LDR. Is it high or low?
Low resistance?
It's low. I mean, and again, it's just lower than it is than when it's dark. Okay, so it's not zero, but it's lower than it is when it's dark. So our third thought is, what about the voltage here? Voltage here. Is it high or is it low?
It's low.
Low, yeah. Because basically, I know, like, if the LDR's resistance is low, it's not going to use up a lot of voltage, right? Remember how I said resistance dissipates volts. So if resistance is low, you're dissipating lower volts. So if the voltage is low, okay, our IB is really small. I'm going to say too small. Too small, in fact, to turn on the transistor. Meaning no current flows here. Okay, so I have to put a big, like, okay, no current flows through the transistor. So what does that mean about our LED?
It should be.
Sorry, you muted yourself, right?
It should be off or dim.
It's going to be off. Remember, we're thinking of this as a switch, right? So it's like if no current can flow through the transistor, no current can flow through this branch at all. Remember how we said electrons are smart. When they get here, this guy is going like, oh, no way, I'm going through that. That's an open circuit. Like, that's infinitely hard to get through, so I can't go through that. So I know that my LED is okay, so again, bright means that the LED is off. And when you go to explain this, okay, when you do this on your quiz, what you're going to do is start with the LDR. Okay, so start with the brightness LDR, then think of the LDR's resistance. Is it high or is it low? And then remember that resistance and voltage are related, right? When resistance is low, voltage is low, right? And then we can think about how much current is going in through the base. If there's not enough current to the base, it's not going to, the transistor is going to stay off, meaning the LED is off. So transistor and the LED are the same. And then like these two states, the voltage and the resistance, low voltage, low resistance, low voltage, and then transistor off, LED is off. Okay, do you guys think you could, you know, if you looked at this a little bit longer, do you think you guys could figure that out? Or like explain it? Is there a question? Daniel, is that your hand up?
I don't know. I was a thumbs up. Like,
oh,
I
okay.
can explain it, I think.
Sorry, I can't. Okay, I'm going to stop recording.